here we want to evaluate the indefinite integral, and the integral is the sine 2x divided by 1 plus the cosine squared x dx. So in this particular problem, what we want to do is we want to kind of manipulate this just a little further, because here we have a double angle with our trig, and so we can substitute this. So let's go ahead and substitute this before we make any substitutions. So we have sine of 2x. Well, sine of 2x can also be the same as 2 times the sine of x cosine of x over 1 plus the cosine squared x dx. Okay, and then what we're going to then do is then factor out the 2. So if we factor out the 2, we're going to get 2 times the integral sine of x times the cosine of x over 1 plus cosine squared x dx. Okay, so what can we do in this particular problem? All right, well, we know that we have this as our integral, and then we need to determine what we're going to let u equal. Okay, so we're going to let u equal the cosine of x. So for step number 1, we're going to let u equal the cosine of x. And so what do we know about the derivative of the cosine of x? Well, step number 2, we're going to let du equal the derivative of the cosine of x, which is negative sine of x dx. Okay, and then we also, if we're going to substitute, we need to make sure that we're substituting with a positive, so we need to divide both sides by that negative sign. So negative du is going to equal the sine of x dx. Okay, so using this, we have 2 times, okay, we have the cosine of x over 1 plus the cosine of x squared times the sine of x dx. Okay, now let's go ahead and do our substitution. So we have the cosine of x, which is u, over 1 plus u squared times negative du. Okay, so now we want to take the antiderivative of u over 1 plus u squared. So before we do that, let's factor out that negative sign, which becomes negative 2 times u over 1 plus u squared du. Okay, now I'm going to pause for this part, and sometimes if you've already solved for a particular integral, you can use what you've already solved for. So I'm going to go ahead and show you what I mean for this part over here. So I'm going to take this integral down here. I'm going to call this the example, right? And then this is u over 1 plus u squared. Okay, now we solved this already when it was in this form, x over 1 plus x squared dx. Okay, and then just like we've done in the past, what we would do is we would substitute. So we would let u equal 1 plus x squared, and then we would take the derivative of that, and we would get 2x dx, and then we would divide both sides by 2, and so therefore we would end up with 1/2 du equals x dx, right? And so that's what we get over here. And so in step 4, if we would rewrite that 1x over 1 plus x squared dx in the form of 1 over 1 plus x squared x dx, and then we would do our substitution. So it's like a problem within itself. So we would have 1 over u times 1/2 du and then we would end up getting 1/2 times 1 over u du, and that gives us 1/2 times the natural log of the absolute value of u plus c. Okay, and then we know that u was the natural log of 1 plus x squared. So this would have been 1/2 times the natural log of 1 plus x squared plus c. Or if we take a look at what this is up here, we now know what that's going to look like. So basically, this is now going to become -2 times 1/2 times the natural log of 1 plus u squared, and then that's plus c. And so now, what did we call u? We called it cosine x. So therefore, this is now going to become -2 times 1/2 times the natural log of 1 plus the cosine of x squared plus c. And so now if we distribute and then simplify, -2 times 1/2 is negative natural log of 1 plus the cosine squared x plus c, and therefore there is your result.